Hello, you 11s! Just so you know, it's quite funny. I'm doing a YouTube video whilst these guys are watching. It's all very strange. Right, I'll share my screen, guys. I'm just going to get straight on with it. Share screen. Go, go, go. I'm also then going to go to my notes and then turn off my camera. Let's see if my laptop crashes. I think if I don't, I think it seems to have figured out. Add to stream. Yeah, my laptop crashed. As I said, I think it's because I had on my other screen, I had my camera. So if I now do it this time, it shouldn't crash this time, guys. Shouldn't crash. Let's try that again. This is a really bad idea. There we go. Didn't crash this time. Winner. Right. Okay. What I'll also do is I will also have that video up there so I can see everyone. Can everyone still mute YouTube? Yes, mute YouTube. Yeah, that's a good idea. Yes, I'd agree with that. Definitely. Right. Okay. So exam review, folks. So you guys have obviously still got the documents that you scanned or even the hard copy that you did. So definitely worthwhile spending the time and going through it. So first question, nice and straightforward. It was actually, you know what? This question caused a whole load of trouble in the GCSE exam. Students didn't understand why it had been negative. But of course, what they'd done is they'd put all the stuff on top of the scales and they'd click the tear button. And then, of course, gas is leaving. So the key thing to recognize is that two gases were being produced. So you had to state, the main one is carbon dioxide. The water will condense on the walls of the beaker, but it was carbon dioxide and H2O are gases in the equation. Gases in the equation. You didn't, and amazingly, you didn't need to mention the water. If you just mentioned that CO2 is a gas in the equation and the CO2 is escaping. And that's the important bit, escape. Yeah, the CO2 is escaping. But now they actually had cotton wool in the top. So if you stated that water was leaving, I think you lost the mark. But because the cotton wool will trap the water will condense and form water droplets in the cotton wool, but the CO2 will pass out through the cotton wool. So the 1 mark was for saying that the CO2 was a gas, it therefore escapes. 1 mark, nice and easy. I would say that you guys were giving very short answers for that, and you didn't actually need to waffle at all, and I was quite happy with them. But I would say, you know, try to create sentences if you can. So, right, okay, so the one was, the mistake has been circled. Right, there were a load of students who came up with an incorrect explanation for this. Suggest one mistake the student could have made to produce this result. So the result should have been here, but it was high. Now, lots of students, so the key things are, so he could have, number one, top answer, used a concentration higher than expected. Top answer. Yeah, expected. However, there were other options. Now, you were allowed to say, that's the top answer, but you were allowed to say red mass too late. So he's timing it, yeah, and then he's been looking at his stopwatch, and then he's looked at the reading on the scale, and he's taken too long to do that. So red mass on the scale's too late was allowed. Now, lots of you guys wrote that he started the stopwatch too late. Well, that's not correct, because if you started the stopwatch too late, then the mass loss would have probably been higher than expected. Sorry, no, hang on a minute. Would have been lower than expected, because essentially, oh, hang on a sec. You're saying that if he adds it and he starts the stopwatch too late, it means that he's still going to record to a minute and get a mass. No, so that's allowed. Stop clock after adding calcium carbonate, left it too late. What other ones would you be allowed? If you started it too early, then that would have given you a lower than expected value. So starting it late, you'd have been allowed. Yeah, but starting it too early, you're not allowed, because if you started it early, then he's going to hit the 1 minute before the reactions got to a minute, so your value would be too low. Those are the top answers. What other ones could we have had? I think that's all they really wanted. Those are the top three even. Next, state the relationship on the graph. This was a very common mistake in the class. About 50% of the students got it. It is a straight line through the origin, which means it's directly proportional. And yes, you needed to say it. One which I thought was entertaining, I think, was Hao Ping. Yeah, he put direct proportion. That's not allowed. You had to say directly proportional. Yeah.
No, I don't think it was me.
Oh, was it not you? Somebody did. Somebody who was a late entry gave me one where they'd written direct proportion, and it wasn't allowed. It wasn't quite right. Wasn't close enough. Yeah, that was a tricky one. If you had a graph that was like this, then you'd say as concentration increases, then loss of mass increases. But because it goes through origin, straight line through an origin, directly proportional. Next, explain why the increase, 2 marks. You had to run the whole of KICAS to get it. But in this case, it was concentration, and they've increased it. So more particles per unit space. More particles per unit space. Now, can I just quickly mention an Edexcel trap? If they had doubled the concentration, then you would actually have to modify KICAS to say that the number of particles was twice as many per unit space. If they give you a scenario where they've actually done a specific increase or decrease, you've got to use that. But in this case, they've just said increases, so more particles per unit space. Therefore, collision frequency increases. Therefore, collision frequency increases. Skip over energy because we haven't changed the temperature. Therefore, more successful collisions. You've got to have all successful collisions. You've got to have all 3 to get those 2 marks. Yeah. All 3 for 2. If you have 2 of them, then you get 1. If you've only got 1 of them, you get 0. Next. Right. I thought this was the easiest question on the paper. Still a few people got it wrong. The apparatus is a measuring cylinder. You weren't allowed just to call it a cylinder. Common mistake. Yeah, you had to say the word measuring. Yeah, which makes sense because a cylinder is just a cylinder. Yeah, that's just a maths is a cylinder. Yeah, but when it's got a scale, it's a measuring cylinder. Somebody said a graduated measuring cylinder, and I thought that was hilarious. A graduated measuring cylinder would look something like, it'd be really weird. Something that's really bizarre. Yeah, the word graduated goes specifically with the graduated pipette. No, hang on a minute. Cylinder. There we go. So a graduated, measuring cylinder. What volume of hydrochloric acid is in the apparatus? 44. Now it's 2 marks. Yeah, so you had 44 was 1 mark, but then you had to give the units, centimeters cubed. Thought that was entertaining. Use it to calculate number of moles. First mark, number of moles is concentration times by volume over 1,000. Loads of people make crazy errors here, guys. Loads of calculator errors being made. It gave you the concentration, which was here, 0.01. Oh, my tablet's taking a break. So the concentration was 0.01. The volume was 44 centimeters cubed over 1,000. Never, ever do it in your head. There are people who are still doing these in their heads and making silly mistakes. 4.4 times 10 to the minus 4. Loads of people were adding hundreds of zeros. If you don't like that answer, shift eng on your calculator and you'll get the normal number. Don't try and count the numbers in your head. Yeah, use the calculator to do this. Yeah, it's such an easy mistake. Yeah, next. Right, this one was one of the more difficult questions on the paper. Lots of people lost 1 mark. So the first thing you had to say was that zinc and hydrochloric acid, the ratio is 1 to 2. That was 1 mark. Loads of people didn't say it. Then what you had to say was that he had 0.0075 moles of zinc, and he had 0.01 moles of hydrochloric acid. Now, at that point, you still haven't gained the 2nd mark. What you then needed to do was to say, well, hang on a sec, I needed twice the amount of, if they're asking which one's in, I've just chosen zinc. If I do 0.0075 times 2, I get 0.015. So I needed that much HCl. Yeah, that was required. And it is simply the case that we haven't got enough. So this is limiting. This is the limit. Therefore, the zinc was in excess. 2nd mark, zinc in excess. So it was technically a 3-mark question, but given only 2. So you had, by the way, you could have done this one if you preferred. Yeah, you could have gone divide by 2 to see how much you needed of that. Yeah, and realize that we've got too much. Could have gone that way as well. But you had to show your working, explain your answer. Without the explanation, you can't get the 2nd mark. And then zinc in excess. So I know excess questions are tricky. I do. They're one of the ones that even at A level, they really struggle with. Next, the student repeated the experiment with 0.0075 moles of magnesium powder. So he used 0.00 zinc powder previously. What's going to happen to the rate? Rate will increase. Change back to red. The rate will increase because magnesium is more reactive. Yeah, rate increase since Mg more reactive, capital M. Mg is more reactive. So definitely going to be a bigger rate. However, if you look at the equations are identical. What that means is the hydrogen gas being made is going to be exactly the same. So no effect, no effect on H2 volume. Now you actually, if you just simply said, rate increase, you gain the mark, and no effect, 1 mark. Annoyingly, it's nice to understand where that chemistry is coming from, because I think most of the mistakes were made because students didn't understand how the chemistry were telling them this. So it's nice to explain that the magnesium is higher in the reactivity series, and it's nice to explain that because the equations are the same, then the H2 volume will be the same. Yeah. Okay, moving on. So that one was out of 9 marks. Next. Okay, question number 3. Right, this question caused a whole load of problems because they didn't RTFQ. Read the full question. Yeah, RTFQ. Suggest the features of the marble chips. People were talking about concentrations. And I'm like, why? The question is about the marble chips. I think this was where Hal Ping lost his mark, because he said the number of marble chips, and that's not correct. You could have big chips and small chips. So you had to say the surface area, same, and you had to keep this the mass, mass of calcium carbonate chips, mass of chips, the same. Yeah, so that was surface area and mass. By the way, just to let you know that surface area and size is the same thing. Lots of people wrote down surface area and size. They are quite literally part and parcel of the same gig. Next, the student should have put some cotton wool on the neck of the conical flask. How would this improve the accuracy? Prevents loss of water or acid through spitting. Yeah, through spitting. I like it. Nice and easy. Next. Right, so use the graph. There's an anomaly. You can see the anomaly. Use the graph to find the time taken for the mass lost at 50%. Right, 2 marks. Show on the graph how you obtained this. Loads of students didn't bother to show their line. Loads of people didn't bother. A couple of people did the wrong square. So it's nice just to me try and line it up. There we go. And then read it off. There we go. So reading was 210. I've no idea why people proceeded to try and take it away. I've no idea why people were doing that. That is the time it took to produce your 1 gram decrease at 50%. I don't understand why people were trying to link it to the 20% one. Very strange, very odd that, but loads of people did it. Very, very odd. So 210 was the answer. Next, right, this one was probably one of the harder ones. So we had to recognize that this was the anomaly, and then we had to figure out what caused it. So A, the concentration of the acid was more than 40%. Well, hang on a minute. If the concentration of acid was more than 40%, it would have been coming down the line. So that can't be true. The loss of mass was greater than 1 gram. Yes, that could be true. The mass of marble chips was more than 10 grams. No, because in the thing, it just says she adds, like, she investigates with calcium carbonate, she gives the bottle container, she uses a method, adds some marble chips. What that means is it's going to be in massive excess. So what that means is, it means that if she's added more, that's not going to matter. It's not going to change the rate. Adding more doesn't make it quicker. Yeah? You get more, but not quicker. The student started the timer too late. If the student started the timer too late, then her number would be small, because instead of starting it at 0, she's starting it here, which means her value would have been smaller than expected, not larger. Does that make sense? Because she still would have, she started it too late. The student started the timer too late. Yeah, because imagine if you're going to end it. Oh, hang on a minute. Start it too late. Oh, yeah. Time in seconds to produce mass decrease. Well, she's watching it and she's put it in and she's watching the mass decrease, but then started it too late. So it appears like it's going to get. Yeah, imagine this as a timeline. Imagine that she adds it here. Yeah, add there. The time taken would be the length of the line. So the 10 gram decrease, sorry, the 1 gram decrease, yeah, is all the way to the end. So let's say that's the time. But if she started it, she added the 1 gram and started the timer too late, yeah, start there, she's going to get a smaller value for the time. It's quite clever that. I'm not doing that diagram justice. I feel like I want to give that another go. So if the mass decrease is 1 gram, that there is 1 gram decrease, and she starts the timer to measure that. If she starts it at the correct time, she will end it at the correct time. If she started it too early, it would have been larger. Yeah, if she'd started it too late, she would have been still ending at the 1 gram decrease because she knew what it read at the beginning, but she's just going to have a shorter time for it, not a longer time. So it can't be D either. So the answer was B. Hope that makes sense. Next, calculate the rate of the reaction at 50%. So it says 1 gram over the top of it, and it gives you the equation, everything you need. 1 gram lost over, what's the time taken for 50%? So the time taken was 210. We had that from our previous question. So 1 divided by 210, sorry, I don't know why I wrote 250. 101 divided by 210 gives me a number of 4.76 times 10 to the minus 3. If you don't like it, shift eng. Yeah? If you don't like it, just use the eng button. Don't try and do it on your own. Yeah, and that's grams per second. Perfect. I like it. Either one of those numbers. 2 marks, of course. 1 for showing that and 1 for showing that one. Next, increasing acid. Oh, so this question was a repeat. So I apologize for this, folks. Yeah, I need to find a better question there. I didn't make the paper. Because it's if you got the first one wrong, then you're going to get the second one wrong. You're running kick-ass on concentration again. But A doesn't apply, we know that. So more particles per unit space. More parts per unit space. Therefore, collision frequency therefore increases. Collision freak increases, therefore more successful collisions. Successful colls. We're done. Rate increase. It's always nice to put kick-ass R. Rate increase. There we go. 3 marks. 1, 2, 3 this time. Isn't that weird? The first one was only 2. You needed all 3 to get 2, and this time it's 3. Shows you what EdXL do and how they change the numbers, depending on if there's too many marks on a paper. It's a different paper, that one. Next time that this paper is done, I'm going to change that question and put in maybe a surface area one, or maybe a pressure in gases, or maybe a temperature. I think temperature would be a good one to go in there, so I'll find a question to slot in there. Right, next thing, give 2 properties of the solution that need to be kept the same. It's concentration. Yeah, concentration and volume. Nice and easy. Most people got it. It's great. Next, it then says, which solid does not act as a catalyst? B. Most people got that one. This one was much more challenging. Which solid is the most effective? Loads of people went for A, but guys, that's not correct. That's the worst catalyst. The time to collect 100 centimeters cubed of gas, well, A's done it in 76, whereas D's done it in 11. D's a much better catalyst. The answer was D. A whole lot of students as well wrote the number 11. Lol. Yeah. That is not solid. That is not the solid letter. So it was annoying that because you had the right answer, but you hadn't written down the correct letter. In the first experiment, the student added 1 gram of A. This is the question which most students have lost their marks on. So lots of people got high grades in this, but loads of students got this wrong. 2 marks. Now, can I just point out, I've been very generous on this question, and I probably should actually take marks off people. But the answer is, so hang on a minute, catalysts aren't used up. So what you should have done is, so it says, describe how what he could do with the contents of the flask at the end of the experiment so that A was a catalyst. So they would filter content. So just filter content to remove catalyst, remove cat. Now this is the mark that most people lost. You had to dry it. Yeah, dry the catalyst. Lots of people just forgot about that bit. If you don't dry it, your mass is going to be larger. Yeah, and then dry and then weigh catalyst, and mass wouldn't have changed. Would not have changed because they never get used up. I like it. Next. So the 2 marks, if you were wondering, I mean, in reality, you need all 3 of those to get it. But if you said filter and weigh, I gave it to you because technically on the mark scheme it says that. It just says in brackets dry, but I would say that in EdXL, there's very, very likely that would be a 3 mark question as well, and they're going to say dry it. So just bear that in mind. Next, you had to plot a graph, nice and easy. So you had to just plot the graph for G. So 0 was 0. Then 20 seconds, so 20 seconds was 36. There. And then 40 seconds was 58. And then 60 seconds was 74. And then, is that right? 60 seconds, 74. Yeah, that's good. And then 80 seconds was 86. 80 seconds was 86. And then 100 seconds was 96. Oh, no. 96. And the last one was 100. Oh, 100. There you go. Right, so then you had to draw your line of best fit. There we go. So that was your line of best fit. I shouldn't have run off, really. Matching it to the curve of my wrist. There you go. So there's 3 marks there, guys, which is great. 2 marks for all the plots being, by the way, I think all of you scored that, which was great. All of you scored all 3. Then it says, use your graph to work out G at 70. Right, find 70. And you had to show it again using a ruler. Rub off all that garbage. And then zoom in using my ruler. Oh, it's sinking. It struggles when it sinks. There we go. Have I gone off the reservation on the other bit? Yeah, no, I think that's all right. Yeah, 70 seconds, ruler. There we go. So now yours, what you realized was that it actually depended on your line of best fit. If your line of best fit was a little bit bigger, which is totally fine. Mine's still not perfect, but I don't mind it. Yeah, might want to go to 80. But the answer was as long as it came off your graph. So the answer ranged from 79 to 81. Yeah, 79 to 81, but you then had to show line on graph. Yeah, so 1 mark for that, 1 mark for your value. Also, I would like to also point out, it's worthwhile putting on units, centimeters cubed on that one. How do the curves of the graph show that the reaction is faster with solid F? F was steeper. F's line was steeper, had a higher gradient. Higher gradient. 1 mark. You also could also say there was another option, which is to say that it reached 100 later than what the other one did. Yeah, you were allowed to say either for that. And that was out of 12. So reached, and you had to say, so F reached 100 centimeters cubed in less time. You should never say the word fast or slow, yeah, in less time. There we go. Right, that brings us to the end of the test. I hope that makes sense. I hope that kind of you've now gone through yours and checked your answers and you saw where you went wrong and that you've managed to make some changes. I'll see if I can turn my camera back on and then return enable. There we go. And then I can return to my YouTube channel. There we go, start cam. See if it works. Come on. That's doing it. There we go. Right, guys. What about linear relationship? Oh, sorry. Mr. Duncan is echoing a lot. Yeah, sorry about that. What if you they recorded for over 1 minute, like a stopwatch error? Recorded for over 1 minute. They recorded. Linear relationship isn't enough, Lynn. Had to say directly proportional. I don't like it, Alison. No, I'm not going to give you. It's vague. Oh, it's all sticky. Right, guys, I'm going to end my chat there at this point because my laptop's having problems. Oh, it's because it's running both cameras. Yeah, I'll end it now. I'll see you later, guys. Could you write policy? No, you can't, Imani. Straight line through the origin, directly proportional.